Hey guys, it's me Nathan guys. As you can see guys, I'm teaching chemistry. These are my favorite topics in chemistry, what I learned based from chemistry 1 and 2. The first topic that I want to share, which is my favorite, which is molar mass. So for number 1, to find molar mass of KAlSO42, I know K is potassium, Al is aluminum, so K, which is potassium, is equals to 39.098 grams, and aluminum, which is equals to 26.982 grams. Then SO4, I forgot what it's called, it's equals to 96.096 grams. Then I add all those three up together, and since it's SO42, I have to do 2 times 96.06 grams. And if I add that in total, it's going to give me 258.2 grams. Now, for number 2, GD3GA5012, as you can see, my work here. So GD is equals to 157.25 grams. Ga is gallium, which is equals to 69.723 grams. Then O is oxygen, which is equals to 16 grams. GD3 is equals to 3 times 157.25 grams plus 5 times gallium, which is 69.723 grams plus 12 times 16 grams, which is oxygen. Then I get in total 471.75 grams plus 348.615 grams plus 192 grams, and it gives me a total of 1012.365 grams. And then another topic that is my favorite, that I kind of like the most. It was before, it used to be a struggle, but now it's my favorite. It's stoichemistry. So for number 1, the human body needs at least 1.03 times 10 negative 2 moles of oxygen, or O2, every minute. If all of this oxygen is used for the cellular respiration reaction that breaks down glucose, how many grams of glucose does the human body consume each minute? So you have C6, that's a 6 guys, not an O. You have C6H12O6, which is sucrose or glucose. I think it's glucose. Yeah, glucose plus 6 moles of oxygen plus, which is equals or related to 6 moles of CO, which is carbon dioxide, I think, I'm not so sure, plus 6 H2O, which is hydrogen, 6 moles of hydrogen. And then first step I do, I set out the equation. They do 1.03 times 10 negative 2 moles of oxygen times 1 mole of 1 mole of glucose over 6 moles of oxygen. And that's going to give me 1.72 times 10 negative 3 moles of glucose. And then to find the molar mass of glucose, I do 6 times 12.01 grams, which is carbon, plus 12 times 1.01 grams, which is hydrogen, plus 6 times 16 grams, which is oxygen. Then I get in total 72.06 grams plus 12.12 grams plus 96 grams, which is equals to 180.18 grams per mole. So the molar mass of glucose is equals to 180.18 grams per mole. And then to find the mass of this, I do 1.72 times 10 negative 3 moles times 180.18 grams per mole. And the mass of this is going to give me 0.31 grams. So this is another question. So you have another question. Another question. 2Na-Na3S, which is equal related to 2Na-S plus 3N2G. And then you have another set, which is 6Na-S plus Fe2O3S, which is related to 3Na2OS plus 2Fe. Now, assume that 65.1 liters of nitrogen gas are needed to inflate an airbag to the proper size. How many grams of NaN3 must be included in the gas generate to generate this amount of N2? How much Fe2O3 must be added to the gas generate for this amount of N3. So the volume of N2, which is nitrogen, volume nitrogen is equal to 65.1 liters. Then the density of nitrogen is equal to 0.916 grams per liter. And mass is equal to volume times density. So mass is equal to 65.1 liters times 0.916 grams per liter. And mass is equal to 59.63 grams. Now to find the moles of nitrogen, you do 59.63 grams divided by the molar mass of nitrogen, which is 28.02 grams per mole, and the moles of nitrogen is equals to 202.13 moles. Now you write 2Na3, which is equal to 2Na plus 3N2. So you have 2 moles of NaN3 times 2.13 moles of N2, because it's literally 2 over 3. So you have 2 moles Na3 and 3 over 3 moles of N2 times 2.13 moles of N2 over 1 mole of N3, Na3, which is about 1.42. So the mass, now to find the mass of this, you have 1.42 moles times 65.01 grams per mole. Mass is about 92.32 grams. So you have another equation to set up, which is 6 moles of Na, which is sodium, plus Fe2O3, which is related to 3Na2O plus 2Fe. So you have 1 mole of Fe2O3 times 1.42 moles of sodium. So you have 1 mole of Fe2O3 over 6 moles of sodium times 1.42 moles of sodium, and that's going to give you about 0.24 moles of Fe2O3. So the mass of this is equal to 0.24 moles times 159.69 grams per mole, and mass is about 38.33 moles. Now this is for chemistry 2. So for chemistry 2, as you can see, guys, it's chemical kinematics. That's my favorite topic, 3 out of 4. So for the hypothetical reaction A, products K is equal to 0.0839 seconds, -1, and the initial concentration of A is 0.640 moles. How long will it take for A to be 66.4% consumed, and what will the concentration of A be after 1 minute? So K is equal to 0.0839 seconds, -1. A is equal to 0.640 moles. So to get my answer, you do 100% minus 66.4%, which equals 36.6%. And 36.6% is equal to 0.336. Or if you want to convert, you can most likely convert this to a decimal. I honestly don't know. Times it by 100, I don't know. But A is equal to 0.336 times A0. And then A is equal to 0.336 times 0.640 moles. A is equal to 0.250 moles. So to find N, you say log or N, A0 over A equals to K plus. And then N 0.640 over 0.215 is equal to 0.0839. And then you do this. N of this is going to give you N of 2.977, which is about 1.09. So 1.09 is equals to 0.0839 T. T is equals to 1.09 divided by 0.0839. T is about 12.99 seconds, which is rounded to 13 seconds. So B, T is equal to 1 minute equals 60 seconds. Na0 over A equals KT. In 0.640 A is equal to 0.0839 times 60 in 0.640 A, which is equals to 5.034. So 0.640 A is equals to E 5.034. A is equal to 0.640 over E 5.034. E 5.034 is about 153.1. So A is equal to 0.640 over 153.1, which is about 0.00418 moles. And the exact answer is A is equal to 4.18 times 10 negative 3 moles. Now, the last question, last topic, favorite topic 4 out of 4 is solubility equilibriums. It's chemistry too, guys. So the solubility of magnesium phosphate is 2.27 times 10 negative 3 grams per liter of solution. What is the KSP for Mg3PO42, which the molar mass for that is 262.87 grams per mole? So S is equals to 2.27 times 10 negative 3 grams per liter divided by 262.87 grams per mole. So S is equals to 2.27 times 10 negative 3 over 262.87, which is about 8.64 times 10 negative 6 moles per liter. So you write the equation first. You have MgS3PO42, which is 3Mg2 plus 2PO43 minus KSP is equals to that, and then it's KSP is equals to 3S3 times 2S2, which is 27S3 times 4S squared, and KSP is equals to 108S raised to the 5th power, and KSP is equals to 108 times 8.64 times 10 negative 6, 5, and KSP is equals to 108 times 4.98 times 10 negative 27, and the KSP for that is equals 5.38 times 10 negative 25. Last question for this. The last question for this is that calculate the molar solubility of silver bromide AgBr in the presence of a 0.010 moles aqueous solution of magnesium bromide. MgRBO2, the KSP for AgBr is equal to 7.7 times 10 negative 13. So AgBr related to Ag plus Br minus. KSP is equal to Ag plus times Br minus. KSP is equal to 7.7 times 10 negative 13. MgBr2 is related to Mg2 plus 2 Br minus. Br minus is equals to 2 times 0.010 moles. Br minus is equals to 0.020 moles. KSP is equals to Ag plus times Br minus, which is equals to 5 times 0.020, which is S. So S times 0.020. So 7.7 times 10 negative 13 is equals to S times 0.020. S is equals to 7.7 times 10 negative 13 divided by 0.020. And S is equals to 3.85 times 10 negative 11 moles. So guys, this is me sharing my 4 favorite topics for chemistry, and I hope you guys find this enjoyable. If you guys want me to post this more, just let me know. Have a great day, guys. Bye bye.